Hey guys, today we're going to be looking at the second part of our review of right-angled trig, and we're going to be looking more at worded style problems. So we need to go through a few things that worded problems are usually going to approach, which is starting off with angles of elevation and depression. So this usually comes up in, as I said, the worded problems that we're going to be discussing. All right, and our elevation or our angle of depression is measured from the horizontal. So you have some sort of observer. This is meant to be an eye. Okay. And from the horizontal, so straight out, looking ahead, you have the angle of elevation goes up, elevation, and the angle of depression is measured from the horizontal down. Okay. So, a couple of examples here that we have. If we're discussing an angle of depression of 20 degrees, okay, do not measure from vertically down up or from some sort of line down. This is what I see the most. It's usually the most common error when we're talking about angles of elevation and depression. What you want to do is mark in that horizontal, whether it's the ground or just some observer's eye line, okay, and then measure 20 degrees downwards from the horizontal. Otherwise, we had the angle of elevation, which is not from the vertical up. Right? It is from the horizontal, then up. So not this, but yes to this. And within our worded problem, particularly in angles of elevation and depression, okay, and the bearings that we'll talk about a little bit later, okay, there are a lot of parallel lines. So what we want to do is quickly review some of our parallel line rules. All right. I call them the Z rule, the F rule, and the C rule, because that's what they look like to me. You have the Z across here. I might highlight that in red. That can be seen. Okay. Z, a very square looking C. Oh, sorry, F. Very square looking F, which is, I guess F is square, but I meant this one here is the square looking C. Alright. Note, get a highlighter. So, in the Z rule, otherwise known as alternate angles, both of the angles that you see here, alpha and that is beta, alpha and beta are equal. In the corresponding angles, again, alpha and beta are equal, so that angle underneath the lines in my F, the lines being the parallel lines that we've been talking about, they are equal, and co-interior is when two angles in between my parallel lines, we have this intersecting line here, alpha plus beta is equal to 180. Now they can be backwards, mirrored, upside down, whatever you want to say, as long as you're paying attention to where these parallel lines are, one of these might come up. We'll look at a couple of examples towards the end of the video. Now, bearings made up of a couple different parts. You're going to have compass bearings and true bearings. But regardless, whenever you're doing a bearing style problem, you want to make sure that you're drawing a diagram and that anytime you've come to a stop along your bearings, you draw a north. That's going to help you to be able to determine unknown angles because our cardinal directions, north, south, east, and west, are my cardinal directions. They're parallel So the two ways that you're going to get compass bearings is either compass bearings or true bearings. Compass bearings is made up of three parts. You have the first part, which is either north or south. So do not start it with east or west. The second part is some sort of angle between 0 and 90, because once you get past that, okay, so up here, if you were starting from north and you went to 90 degrees, then you're suddenly east. Each of these are 90 degrees apart, making the full 360. So if you went north 91 degrees east, doesn't quite make sense because once you're past 90, you're traveling away from east. But you would start saying south 89 degrees east and coming back the other way. So back to the three parts, north or south, the angle that is between 0 and 90, and then which direction you're turning in. Is it towards the east or is it towards the west? And then if it's just pointing towards north, south, east, or west, you don't need to say north 0 degrees east or west, you just say north. Okay. The other part is the true bearings, and you have true bearings are made up of 3 digits, despite it being what we would normally recognize as a 2-digit number. 40 degrees, all right, you would write as 040 degrees true. Sometimes might just say a bearing of 40 degrees like that. It's still talking about true bearings, and you might see that in some questions. Anyways, these bearings are a little bit different to our compass bearings, where you can start from north or south. These are always starting from north, and it is always going clockwise. Okay, take a look at a couple of examples for our compass bearings. Okay, we have north 30 degrees east. So we've started at north and we've turned towards east, and we've turned 30 degrees and we'll start heading in that direction. Okay, that's the bearing. If you have south 20 degrees west, you're going to start from the south line here, and then you're going to turn towards west until you've made an angle of 20 degrees. It might be a little bit hard to see. Scratch that. 20 degrees. It's mildly better. Now note that sometimes you'll have the comparison south 20 degrees west. What is this as a true bearing? Okay. What is the angle to get from north traveling clockwise all the way to this line here? Okay. Well, to go from north to south, you've got to turn 180 degrees plus the 20. So 180 plus 20 is 200 degrees true. All right. If it was a true bearing, again, starting from north clockwise, all the way, 180 is south, plus another 40 degrees, so 220 degrees is that full turn, 220 degrees, not 22, and that's the direction that we'll head. That was terrible. Start from the origin, not from where you started to circle. Okay, and then that there, and you might just label 40 degrees in here rather than the full 220. Okay, because between south and the bearing that we're going to be traveling in is only 40 degrees. But you can write it as the full 220. So a bearing of 80 degrees, we're starting from north clockwise, and we're going 80 degrees. and we'll travel in that direction. Okay, let's try a couple of examples using either elevation, depression. So we are trying to find the height of a tree that makes an angle of elevation of 21 degrees from a point 12.9 meters out from its base. Now, I would recommend anytime you're doing a worded problem that you draw some sort of diagram. There's my tree, that's what I'm trying to find the height of. So how tall is this thing? Okay, and I've got some person that is 12.9 meters away from the base of the tree, and he's looking up to the top, which creates an angle of elevation of 21 degrees. And we're trying to find that part there. So the tree stands perpendicular to the ground there. We have a 90-degree angle triangle, and we're going to go, all right, what two sides are involved? There is the opposite side, because this is the hypotenuse, opposite, adjacent. We want to tie 3 bits of information with this angle. Opposite, adjacent, that's tan. Okay, so tan of 21 degrees is equal to x on 12.9. So x is equal to 12.9 times by tan 21. Go to your calculator, still check that it's in degrees. It's not the brightest calculator, I might switch to this instead. Okay, we have tan 21 times by 12.9. And you can actually change degrees and radians by clicking on here if you have your TI. Just go to 2 decimal places, 4.95 meters. Program 4.95 meters. All right. We have a boat that is 34.7 meters out from the foot of a 25.3 meter high cliff. What is the angle of depression from the top of the cliff to the boat to the nearest degree? So we have some sort of cliff, and we have some sort of boat. The boat is 34.7 meters out from the foot of the cliff, which is 25.3 meters high. What is the angle of depression? Okay, so from the top of the cliff, there was somebody there, they're looking down at the boat, and our angle of depression is always measured from the horizontal down. We're trying to find this angle. With our parallel line rules, the horizontal is parallel, so your line of sight looking straight ahead is parallel to the ground, or in this case the water. So using the Z rule, okay, you might see the Z here. And this is also theta due to our alternate angles. So with this angle now in play, we can have a cliff is standing perpendicular 90 degrees from the ground. Opposite and adjacent, we have tan of the angle of depression, okay, which is also the angle of elevation from the boat to the top of the cliff. You could think about it in the opposite way, but this is how the question is phrased. Tan theta is equal to opposite 25.3 over adjacent 34.7. So theta is equal to tan to the negative 1 of 25.3 over 34.7. Back to my calculator. 10 to the negative 1, 25.3 divided by 34.7. And the question has asked us to go to the nearest degree, which was 36. Keep going, much longer. We've got 2 more examples to run through. This time they're going to be about bearings. The plane flies from Melbourne on a bearing of 47 degrees for 512 kilometers. How far north of Melbourne is the plane? So let's say that's Melbourne. That is my northerly direction. Okay, always start drawing north, and we're from a bearing of 47 degrees, so they're starting north, going clockwise, and they're traveled in that direction. Now I need to extend this line a bit, and that is 47 degrees, and they're traveled 512 kilometers at this point. Okay, if I was to connect the point that plane finished with my north line, we have a 90-degree angle triangle here, and we're trying to find how far north of Melbourne is the plane. Okay, so we're just trying to find the north component, how far it has traveled from here at Melbourne straight up in the north direction. So what is this? Now, we have the hypotenuse, we have the adjacent cos, so cos of 47 degrees is equal to adjacent over hypotenuse, which is equal to, so x is equal to 512 times cos of 47. Back to the calculator, 512 times cos of 47. Alright, it's giving me an exact answer, which I would like to convert to decimal. Alright, the other way you can do it is Control Enter, and that would do the same thing. So x is equal to 349 kilometers. Let's just say to the nearest whole. Alright, 3 significant figures in my answer. I can just justify that because there's 3 significant figures in the question. So, last one. Andrea leaves her house and rides her bike south for 3.7 kilometers. So here is where her house is, and she travels south for 3.7 kilometers. Then she turns and rides directly east for 4.3 kilometers. What is Andrea's bearing from her house to the nearest degree? So let's connect up where her house and where she finished. Okay. It suggests you write north in at each stage, so let's do that. It's gone direct. Andrew's gone directly south here, so it's the same north in that direction. North and east are at 90 degrees to each other, so we have a 90-degree angle triangle, but what angle are we trying to find? Okay, the bearing means we're traveling from clockwise from north. That there is the angle that we're trying to find. We might split it up into 2 parts. Okay, I'm going to chuck in east in here. Alright, east and east are going to be parallel. So this angle, just between the east line and the line that gets us to Andrea here, which I'll label Andrea there, is equal to this one here. And this between north and east again is 90 degrees. It's getting a little busy as a diagram, but we shouldn't need to add anything else. If we can find out what theta is here, we add the 90 degrees, and we should be able to find out the total bearing, the angle from north all the way around to Andrea there. So, how do we find out theta? Well, we've got a 90 degree angle triangle, opposite and adjacent, because this is my hypotenuse up here. Alright, don't want to double up the h's, otherwise it's going to get confusing. So, tan of theta, which I am trying to find, is opposite 3.7 kilometers over adjacent 4.3 kilometers. Probably don't need the units there, but not a big deal. Making theta equals to 10 to the negative 1 of 3.7 over 4.3. We only need to go to the nearest degree, so 10 to the negative 1 of 3.7 divided by 4.3, and we get approximately equal to 41 degrees. Now that's not the final answer, okay? That's just the angle theta in here, the bearing, so Andrea is at a bearing of 90 plus 41, or 131 degrees. Cool. Well, I hope that helps you out. Let me know if you've got any questions. See you next time.